Hey, my name is Matt. I'm going to be demoing the Zerologon exploit for you. This demo is going to be about 4 parts. This first part, I'm going to go over the requirements for actually carrying out Zerologon. Second part is going to be a very quick walkthrough of the code for the script that I'm using. The third part is going to be me actually carrying out the attack. And the fourth part is going to be a showcase of what you can do once you have carried out the attack successfully. So for the first part, requirements, you're going to need a Kali Linux machine. I'm using a virtual machine on VMware for all of these, for this whole environment. I recommend Kali Linux for this because it comes pre-installed with a lot of the packages that you need. Namely, you're going to want Python 3 and you're going to want Impacket. Impacket is a series of classes and modules for Python 3 that essentially allow you to construct packets. In this case, we're going to be constructing netlogon packets that are going to be used for the various calls to netlogon that we need for this attack. As well, Impacket has some functions that we can run in the terminal, some scripts rather that we can run in the terminal that are going to give us further access to the domain. We're going to be using one called secret stump that's going to give us all the credentials. We're going to be using another called wmiexec, which allows remote access to the command line after we use our Zerologon attack script. So for the Windows Server, I'm using Windows Server 2016. This is a domain controller. You're going to need to know some information about this domain controller before you carry out the attack. You'll need to know the name. So mine is sec_dc. You're going to need to know the domain name, which is secure.system. And you also need to know the IP address. In addition to knowing these things, you also need to be able to establish a TCP session with the domain controller, which is why this attack can sometimes be considered an insider attack, because you do need to have some level of access to the domain controller to begin with. Despite that, this is still a very dangerous attack, even if you need those prerequisites. So Zerologon was patched in about September of 2020. I'm not exactly sure when this build of Windows Server 2016 is from, but it is vulnerable. Any version of Windows Server 2016, 2019, 2012, etc., any domain controller running on those versions of Windows Server that have not been patched since September of 2020, we'll say August for some simplicity, anything not patched before August is going to be vulnerable to this attack. So that about wraps up the requirements. We'll move on to the next part now. So I'm going to go over the script very quickly that I'm using called setEmptyPassword. Starting off with the imports, we're importing a module called nrpc from Impacket. This is the most important module that we're importing. It's going to give us all the netlogon functionality for our script. All of those calls that we mentioned in our presentation are coming from this package, this module. Let's scroll down to main. The arguments that we're taking in are going to be the domain controller's name and the domain controller's IP address. You'll see me type those in when I actually run the script in the next step. The first thing we do after that is set RPC connection to none. This is just a variable called RPCCon. It's going to be equal to none. We're going to start a loop. That's going to loop between 0 and max attempts. Max attempts is set to 2000. This RPCCon variable is going to be set to the value of try0 authenticate, which is our main function. It's going to be actually carrying out the exploit. If at any point RPC connection comes back to us and it's not equal to none, the loop is going to break. Going to hit this if statement. This if statement is going to resolve to true, and the attack will be a success. So what exactly is going to happen in try0 authenticate? Let's go find out. this is the function here. We're going to skip past these first 4 lines. We're just creating a TCP session with the Netlogon service, and we're going to get to here. I'm not going to explain this too much because we went over it in the presentation, but we have the plain text of 8 bytes of 0 and the ciphertext of 8 bytes of 0. This is the flag that we mentioned in the presentation where we're disabling sign and seal, essentially telling Netlogon that we do not want encrypted transmissions because we don't have a session key to encrypt them with. So the first call that we're making is the request challenge. We're putting in the 8 bytes of zeros into the request challenge, and then we're immediately going to be sending a NetRServer Authenticate 3 call with the ciphertext of 8 zeros. We're also going to save the response from Netlogon in a server auth variable here for later on. So most of the time, 255 out of 256 times, this is not going to work. The ciphertext will not be 8 bytes of zeros. In that case, we're going to hit an exception here, and there's going to be an error code that it gives us back, which is specifically this error code, which just means that we have our access denied. It's going to return none. That means RPC connection is going to be none. This will not be true, so it's going to increment. It's not going to break, it's going to increment the loop, and we're going to try again. So that's how the brute force comes in. We're just trying over and over and over again until we hit the 1 in 256 chance where the ciphertext is all zeros after we send a plain text of all zeros. So we saved the server auth, which is the response from the server, and it's going to have a field called error code. If it was a success and we hit that 1 in 256 chance, the error code is going to be 0. So that's what this line says. If that's the case, we're going down into here. I'm not going to go over the authenticator because we mentioned that in our presentation, but I will be discussing this right here, this NetRServer password set 2. We mentioned this in the presentation as well. This is a call to the server, or the Netlogon service rather, to set the password of the machine account, which is what this line is, target computer plus $sign. That's going to be the machine account of the domain controller. And this is the password we want to set it to, which is 516 0 bytes. So this is going to resolve to an empty password. So after this call goes through, the machine account of the domain controller is not going to have a password anymore. And this line just sends that password set request. So when that goes through, as long as there's not an exception here, it's going to return the RPC connection. So we're going to end up back here. RPC connection is now actually going to have information in it. It's not going to be none anymore, which means that this if statement is true. It's going to break out of the loop. This if statement will also be true, and we're going to print that the attack was a success. And that's very quickly and briefly an overview of how the set empty password script actually works. So for this third part of the video, I'm going to be actually executing the set empty password script, as well as the 2 other in-packet scripts that allow us to access the domain controller as a domain admin. So to start, I'm going to move over to my documents folder. That's where I left the script. And I'm simply going to execute Python 3 set empty password.py. I'm going to supply the domain controller's name. Like I said, you do need to know this, as well as the IP address, 0.10, and that should be good to go. And there we go. It was as easy as that. As you can see, that took a matter of seconds, and now the domain controller's machine account has a completely empty password. So let's move on to the secrets dump. So we're going to run inpacket-secrets dump. We're going to target just DC, which means just the domain controller. We're going to add the no pass option, which means we don't want to input a password. We don't need to input a password because there isn't a password. And we're going to be targeting the domain secure.system, the account rather, sec_dc, And then we're adding a \$ So this is just, oops, this is telling it that it's the machine account. And the machine account at the IP address 172.160.10. And we will input that. And here we go. These are all of the domain credentials. And there's also some Kerberos information as well here. What we're interested in though is this administrator account. This right here is the administrator account's password hashes. We're gonna go ahead and copy these, and we're gonna move on to our next script, which is going to be inpacket-wmi-exec. We're going to be targeting the domain secure.system and the user administrator at 172.160.10 with the hashes option enabled because we don't know the password. We're going to be logging in with a hash, and then we are going to go ahead and paste. Oh, what's this? Paste clipboard. There we go. And that looks good. We'll hit enter. And as you can see here, we have actually managed to get into the command line of the domain controller. So as you can see, that took, a minute or two, and that was while I was explaining things out loud. So if I was just trying to execute this as quickly as possible, you could even script all of these if you really wanted to and execute this attack and get onto the command line as a administrator in a matter of like 30 seconds. So this is an incredibly quick attack, given how extremely dangerous it is once you get onto this command line. And I'll be showing you something you can do in the next part. So in between cuts there, I just changed my directory back to the home directory. And before I show you what exactly you can do with this command line as an administrator, I'm just going to go over to the domain controller and show you one of those side effects we were talking about with the DNS. So this is one of the impacts it's going to have. Now, right now, the DNS is functioning fine, it seems. But if I restart the computer, I'll do now. And while this is restarting, I'll just do a cut back to when it comes back online. But the DNS manager should actually stop functioning. And we're going to look into that just a little bit and talk about what exactly you can do as an attacker to avoid the DNS manager getting all messed up. Okay, so we are back to the domain controller. And if we try and go into the DNS manager now, you can see that the server sec_dc.secure.system could not be contacted. Access was denied. Let's add it anyways. And let's try and manage our DNS. And would you look at that? Not only are we not able to manage this system at all, the other entry here in the DNS manager is also missing. So DNS management is pretty much off the table. The DNS, though, from the bit of testing that I've done off of the recording, does still function fine. I couldn't find anything wrong with it. I just did some basic testing though. But from this alone, an administrator is going to know that they have been compromised in some way, or there's obviously some issue, right? This is going to cause an administrator, if they find out I can't manage my DNS anymore, they're going to look into it. They're going to figure something out. They're probably going to notice eventually, from their logs that the machine account's password was changed, that, there was a bunch of random netlogon requests, that someone executed secrets dump. So this is going to get you noticed pretty quickly. However, as you saw, there was a window of time there where the DNS manager still functioned fine. And you can avoid it ever getting to this point if you reinstall the original machine account's password. There is a way to do that. I'm not going to get into it because it's going to take a little bit too much time, a lot more time actually than we have for the demo. So again, not going to go over it, but it is possible. You can find scripts that'll do it, where they essentially are reusing that Zerologon vulnerability to change the machine account's password back to what it was before, but that's only after you have managed to wmyexec in and save some registries from the local machine that hold that machine account's password. From there, you can re-enable the original one, and you're never going to get this error, so you're going to be a lot less detectable if that is the case. However, we're not going to worry about it, like I said, and we're going to come back over here. Oops. We're going to have to reconnect with wmyexec. Shouldn't be a problem. And we're going to go over what exactly you can do with this this command line that we have here and administrator access. So wmyexec has a nice little command for us called put. That is going to let us take a file from our local machine and put it onto the domain controller. Now, what kind of files can you put? It seems to me that you can put pretty much anything at all, and especially useful to us is that we can put executable files on there. So I'm going to go ahead and execute a put with one of my favorite files, fakevirus.bat. And we're just going to put it right on the C drive. Doesn't really matter. And now, because we're an administrator, we can go ahead and run fakevirus.bat. Now, obviously, this isn't a real virus. What's going to happen is the domain controller is going to shut down from this executable. The reason I'm showing you this is because if you had legitimate malware and you were legitimately a malicious user who's executed Zerologon, you could upload any number of things to do any number of tasks. And if you combine that with the ability to reinstate the original machine password and kind of hopefully slip a little more undetected into the system, you can do some very sneaky things where you're stealing information off of the domain controller or off of the domain in general, without anyone, hopefully without anyone noticing, or hopefully if you are a malicious person, hopefully you get noticed if this is your domain controller, or hopefully you notice if this is your domain controller and someone uses this against you. Or you could go and want to be noticed. Perhaps your virus in this case is ransomware. Perhaps it's a destructive virus and you're trying to destroy as much information and deny as much service as possible on the domain. The possibilities really are completely endless at this point. You can just use whatever malware you want, and because you have administrator access, it's going to run when it tells you, when you tell it to run. So let's go ahead and run fakevirus.bat. And there we have it. My ransomware has been successfully installed onto the domain, and any moment now, it looks like it'll be shut down. I think soon I will be the owner of 10 Bitcoin. But that just about concludes this demonstration as well as our presentation. Thank you very, very much for watching, and I hope you have a fantastic day. Following this, I'm going to put the references for our presentation up on the screen if you want to pause and take a look at them. Thank you very much for watching.